All right, so kinetic energy. Again, I'm starting with those of you who are online because the rest of the class is not paying attention. Ahmed, do not help them on the project because they need to do it themselves. Exactly. So do not help them on the project because you're not the teacher. I don't want them just given the answers. I want them to have to figure it out. So kinetic energy. This should not surprise you. It's the energy of a moving object. Kinetics, kinematics, kinetic energy. Yeah, kinematics was the study of motion. Kinetic energy, energy of moving objects. Kinetic coefficient of friction, the friction due to a moving object. So similar to potential energy, this is scalar. This is measured in joules. That's, yes, I know you took this last year. That's why I'm doing both of them today. Yep. You'll see that today. Is there something else? Yep. So here's the equation for it. Half mv squared, where you got mass, you got speed. Notice I use speed here and not velocity. Why did I use speed? Because it's moving and because it's scalar. Yep. So even though it says v, it should be speed. But if I give you the velocity in the question, how do you turn it into speed? Take off direction. Take out the direction. So really not too hard. If it has direction or not. Yeah, take it just in case. Yeah, it's because it's scalar. Scalar, no direction. Vector with direction. Yeah, we do. So here's an example. We've got a student running at a uniform speed. What's the kinetic energy? I'm not going to insult your intelligence by explaining this in a lot of detail. But simply take kinetic energy. You've got the equation. Plug in your numbers. Do not forget the squared. The squared, any number squared is like the death of so many students. It's the same in kinematics with VF squared equals V naught squared. So many missed squareds. It's even on the formula sheet. 30 times 5.7 squared, no idea. Number. It gives you a number. Perfect, yeah, write that down. So, joules as well. Energy, joules. So I'm pretty sure you should all be able to plug this in your calculator and get a number. Dynamics. Maybe dynamics will appear. Anything from previous units is fair game to incorporate in this. Probably. Like I said, anything's fair game. So now we've got kinetic energy. We give you the kinetic energy. This is just 1,000. So times 10 to the 3, move this 3 spaces. If you like to use 1,000 instead of this, by all means. So we've got EK, same equation. I just give you different variables. So I give you the energy. We know the mass, or do we know the mass? We do know the mass, 2.1. I didn't see it. 2.1. I need to solve for velocity. Speed, yeah. I said velocity. So v squared is 1,000 times 2 divided by 2.1. You do not put it in the square root first. Square root at the end. And that's why you would get the question wrong. Squared happens last. You take the square root to get it last. Times this, divide by this first, then square it. So, stupid calculator can't do it without being turned sideways. So my square, where's my, there it is. So we get velocity of 30.86 meters per second. Yeah. Also divided by 2.1. You divide by this and then divide by this. So you have to divide by both. No, because you're not timesing by these. It's 1,000 divided by this, divided by this. Because algebra. If it's times here, you need to divide.
Sorry, Mr. Bill just wants me to give grade 10s and 11s a reminder that after you get back on April. Hello. On April 14th, you will be doing your literacy assessment. Okay? During Ramadan, but you can't do anything about it. April 14th is your literacy assessment. Okay? Sorry.
It's okay. I think both the numeracy and the literacy assessment are both in the same week. Yeah, so now you do. Because you need to take this in order to graduate. If you don't do the assessments, you don't graduate. I just know your numeracy assessment is April 14th or 15th. I think you guys are on the 14th. Numeracy. Literacy is, I think, before that. No. Because you can then maybe there's a mix-up. I have it on the email. I'll take a look. Yeah, I can talk about that later. So we can do something fancy with this. Ooh, net force. Someone was asking about, does dynamics come back into this? So if the net force acts on an object, then you have to accelerate. Right? This is Newton's laws. So therefore, this acceleration is proportional, just meaning as one of them increases, the other increases. Hey, Kanawi, Ziad, and Fouad, can you guys talk a little bit quieter, please? Because your noisiness is causing distraction over here. Thank you. Therefore, this. So, here is this is what's called the work energy theorem. If you're going to continue on in physics or engineering, you will see this a lot. Work energy theorem is quite popular. So all this is saying is work is equal to F net times distance. So that's just a variation on what you've seen at the beginning, equals change in kinetic energy. Meaning, if you have a net force, you're going to accelerate, and that acceleration is going to cause a change in your velocity, or your change in speed, which means change in kinetic energy. Work. Same as yesterday. F net causes acceleration, which changes your kinetic energy. So if you watch yesterday's video, it talked about using force applied, or it talked about using force of friction. The reason, and it clearly stated, do not use F net. But here we're using it because it's specific to changing my velocity. So if you accelerate, your kinetic energy is going to change. So you're going to use this quite frequently.
So if there is change in kinetic energy, that's the same as change in velocity?
Yeah. I mean, you can also have a change in kinetic energy if you change the mass, but there's very rare cases that you'll see a change in mass. Sometimes, very rare. So let's give this a try. So if we've got a sprinter exerting this net force over a distance, what's his change in kinetic energy? So this one's pretty straightforward. We just take our work energy theorem. We have F net, we have a distance. So really not too hard.
Do we have to write W equals?
I'm wrote the W so you can see where this is coming from. On a test, if you just wrote F net times D equals change in kinetic energy, that's fine. I'm in the middle of marking your forces test right now. I'm still having a lot of students not writing out the equation. Mohammed? So there are lots of students who are missing out on a very easy mark. Because if you don't write the equation at the beginning, and you just put numbers in here, if it's wrong, you get no marks. There's a mark for the equation, and a mark for getting the right answer with it. So by you not showing the equation, you don't get any part marks. So make sure when you're doing the test, you put your equations. That should be the very first thing you do. So I've got so many people, they skip out on writing something like this, and they simply just ignore that part, and they go like this. Yeah, because where does this come from? I don't know what you're solving for. You've got some number equals a number times A. What are those numbers? If you happen to get it right, yeah, because then I know what these numbers are. So always show the equation because the equation's worth 1 mark. If you know the equation, it takes 5 seconds to write it down. If you don't know the equation, well, you're probably not going to get any marks anyways. Exactly, because if you can put the right equation, that shows you know how to start the question. That's half the battle. I want to get it done by the end of the day tomorrow. I want to get that test marked by the end of the day tomorrow. I don't want to take it over the break. Well, I'm going to the Red Sea. I have other marking to do, so I'm just trying to get rid of as much as possible. I don't know. Use a calculator. Is this the last question? Yeah. Okay. One more question and then we're done. I'm with you on that. Okay, so we've got a student pushing a crate. It's initially at rest. Oh, here comes kinematics. With a force of 160 newtons over a distance of 15 meters. If there's 75 Newton friction, what's the final speed? Ugh.
We don't even have the...
So, here's a giant question with a lot of numbers. So, lots of you are going to see this on a test and freak out and ask me tons of questions. Most of them I won't be able to answer. So what is a good first step to do if you're given something like this? I don't even remember how to solve this question, so this is fun. So what's a good strategy to do? Before that? Yeah, try and figure out what do you have. So let's read this again. A student pushes, we got a mass. Perfect. Crate, which is initially at rest. So I got V initial equals 0. We got a force. What kind of force is this? Okay, we got an applied force. We got a distance. And we got a friction force. Ooh, I could be really cruel with this and just give you the coefficient of friction. That'd be fun. And what are we looking for in this case? What am I looking for? That's not. So I hear a lot of complaining with me adding units on top of units. But guess what? You've got a final exam. And guess what's coming on that final exam? All the units. So by showing you these multiple times throughout the year, it helps you to remember it. Because what do you think is a much better way to remember something? Cramming in 3 hours right before the test? Or studying it once every week?
3 hours before the test.
Definitely. And that's why you're not doing so well. T's a different story. There's other things to talk about with T. So, now, just wait. I want to finish this, and then we can joke around with that. So, now that I've got all the different variables with this, what you want to do is you want to try and figure out what would get me what I'm looking for in this case. So let's take an inventory of everything we have and try and see what I can do. So listen to my thought process, because I'm going to talk you through this because I don't remember how to do it. So what I'm going to do is I'm going to look at this and see, okay, I've got V initial, V final, a distance. Okay, in all likelihood, I will have to use kinematics. Somewhere with that. I've got force applied and force of friction. So I know I'm going to have to deal with dynamics. So basically, I'm going to take everything and I didn't need to put it in this question. So with let's look first at kinematics, because that's ultimately my goal, is I want to figure that out. So VF, V naught, distance. So the equation I'm going to use for this is going to be VF squared, don't forget the squared, is VI squared, not equals, plus 2AD. Now, the problem with this is I don't have acceleration. But if I'm going to deal with acceleration, another thing that I'm dealing with is forces. And how do I get acceleration from forces? My F-net equation. So before I start writing out what my F-net equation is, let's take a look at our free body diagram so I don't mess up my F-net equation. So it's initially at rest, it's pushed with a force, I've got friction. So I've got some force applied, it doesn't tell me direction, minus a friction force that must be smaller because I'm not coming to a stop. I've got Fg, I've got F normal, these are equal. So to make my F-net equation, it's the winning force, which is force applied, minus my losing force, which is force of friction, and then I'm needing to figure this out. So F-net, ma. I have mass, we're good with that. I'm looking for A, force applied, we know that, force of friction, we know that. So we're good at this point to solve my question. Notice I'm ignoring everything else that's going on because I'm trying to teach this instead of have a whole bunch of teachers trying to teach it at the exact same time. So my mass is 25. My force applied is 160 minus force of friction. It's like I know how to teach because maybe I've taken a whole year of studying how to do that. And then in addition to that 8.5 years of experience. So then I need to solve for acceleration. So my acceleration, I'm going to plug in these numbers and I'm going to get a number. Did someone do this? 85. 85? No, what's my acceleration? 5.6. Okay. So 5.6. 6 meters per second squared. From here, we are now going to use this. I need to solve for VF. Go sit down. Then I need to plug these numbers in and solve it. You can figure this out later. Go sit down. Go sit down. If you have a problem with your calculator, that's half a mark off of the test. It's not that bad. Okay? Talk about it later. So I need to solve for VF. Plug in VI, it's 0 squared plus 2. I have the acceleration. From here, I'm good to go. I have a distance. And then do this, square root it. You get an answer. So this is the strategy you go through. This actually looks a whole lot like what you did on your test. Right?
Yeah.
Where's energy in this question? Where's energy in this question? No, but this is in the energy unit. Did I use energy at all with this? No, I didn't. So there's actually multiple ways I could do this. So in this is one way you could do it.
And you can do that on the test?
I'm probably going to say make sure you do it with energy. Staple it and then undo it. Because like I said, I didn't know how to do it, so I just solved it by doing it. This is what I like better. So let's now take a look at this with energy. How would you go about solving this with energy? You can't hear me? Oh, that's because there's too many people talking in the room. Imagine that. Yes, Mohammed, for once this wasn't you. So let's try this with work energy theorem. So I'm going to leave this up here because we like it. So do I have F net? I know what F net is due to this. What did you said it's 85, right? So this, ignore solving for acceleration. Is equal to 85. Okay, we got that. Do we have the distance?
Yes.
We need to do a change in kinetics. So let's just do this. So 85 times the distance 15 is equal to EKF minus EKI. What is EKI? Initial. Yeah. And what is it? What's the number for it? 0. Why?
Because
If I start at rest, a half mv squared is just going to be 0. Thank goodness. Let's just do that. Someone calculate 85 times 15 for me, please.
I don't need to calculate.
Half times the mass times VF squared. Notice I'm dealing with VF. So take this, times it by 2, divide by 25. Because that's the equation for EKF. It's asking for final speed. I need to get final speed. Yep. So times that by 2, you get 2,550. 2,550 divided by 25. I'm not going to do that.
So, Matthew, we write the initial kinetic energy this.
Sir, but the whole equation gave me 100. Sir, the whole equation gave me 100.
Good.
Are you done?
So on your test, I'm going to say you need to use energy. I will say this specifically. So even though I did it originally with that, it's pretty simple to get it back into this. So that is
Wait,